the last episode of the Nothing Personal show, we discussed an intelligent e commerce application and we just started off building that hands on. We spoke about Polyglot Persistence, which meant we used four different database and storage systems for our use cases needs: AlloyDB, MongoDB Atlas on Google Cloud, cloud storage, and BigQuery. MCP Toolbox for databases as the unification data layer. It allows for this multi-database system abstraction from your agentic application or the AI or the web application front end that you're building. Before we get into the hands-on and dive deep, let's take another quick look at the architectural diagram. As you can see right here, we have MCP Toolbox for databases that's deployed on Cloud Run that interacts with all of these databases, and your application, the Python Flask web application that you're building, is completely abstracted away from the data layer changes that we intend doing. Let's get started. To begin with, set the stage for development. Make sure you have an active Google Cloud project with an active billing account. If you don't have an active billing account, you can use the one that is linked to in the project's description, where you can get a $5 trial billing account that can get you started with this application. Next, enable the required APIs and configure all the four data storage systems. Here we have AlloyDB, followed by MongoDB Atlas on Google Cloud Platform, and then we have cloud storage and BigQuery. All of the steps that are required to have this configuration done are listed in the blog. Toolbox. To install it, go to the MCP Toolbox for Databases GitHub page, copy the commands for installing Toolbox as a binary, navigate to your Cloud Shell terminal, navigate into your project directory and any directory within that where you want to install MCP Toolbox for Databases. Execute this and you should see Toolbox installed and ready to go. Tools.yaml. This is the central part of the architecture where we are bringing together all the 5 databases, unifying them here and abstracting it away from the scope of the web application. So here it goes. We have all the 3 sources listed here, and then we have the tools listed. We have the AlloyDB tools here to get product core data, to update stock data, to search product by name, and finally to list all products from the inventory table. As you can see, the logic itself is a SQL query that you write here for each of these tools. However, it's a little more sophisticated than this. You have more advanced configurations and options available for defining your tools. Please go ahead and check MCP Toolbox for Databases documentation for more information on configuring your tools or defining your tools. Moving on to the MongoDB tools, as you can see right here, you have fetch flexible product details tool. Then you have a tool to even write your user interactions of the products into the interactions collection. And you also have a tool for the analytics load into BigQuery. As you can see right here, we have interacted with so many different structures of data within one file, which controls and defines all your tools and the business logic behind them. All right, now in order to test the tools that we have just created in the tools.yaml, go ahead and run /toolbox space --UI to get your toolbox server running locally. So you're able to view the tools in an interactive user interface. There we go. Let's go ahead and take a look at the tools that we have listed in our tools.yaml. Let's test out. So I'm going to list all core products by just clicking Run Tool. And there we go. We've received the JSON response of all the products along with the corresponding details from the database. You can also kickstart the analytics job or anything that you have defined in your tools.yaml from here just for testing purposes. Of course, for integrating this with your application, we will have to deploy this MCP Toolbox or databases instance in Cloud Run, which is serverless and is really easy. It's just a one command thing from Cloud Shell terminal to get this, or from your IDE to get this deployed to Cloud Run. The details are there in the blog that I previously mentioned, so it's easy for you to just follow it from there. So once the Cloud Run deployment is complete, the next step is to just bring this endpoint to your application and have it all integrated. Now let's see how a deployed Toolbox endpoint communicates with our application. As you can see right here, I have defined the toolbox underscore URL variable with the environment variable of the Cloud Run deployed toolbox endpoint. And using that, I'm interacting with the toolbox LangChain library using toolbox client. And that's it. After this, it's pretty much using toolbox to directly invoke the tools. Now let's see it in action. We have our Polyglot e-commerce application running with data from across multiple data structures, formats, and databases. As you can see right here, some of these product details are coming from AlloyDB, some from MongoDB collections, and some are coming from cloud storage, basically the unstructured image data. And every interaction that I'm having here with the products are being logged into the MongoDB interactions collection. And we also have the ETL section functionality where you can run an ETL job by extracting MongoDB interactions and merging them into BigQuery. So now we have more data to process. And as you can see right here, the top 5 most viewed products are also refreshed depending on my recent interactions with the products in this application. That's it. How incredible it is that we've gotten to a point where we don't need to change anything in the application or the agent itself for the data logic change. Check out the GitHub repo link in the caption and try it out for yourself.